Uh, we're doing a problem in normal distribution. An industrial oven is used to cure sand cores for factory manufacturing engine blocks for a small car. And the oven is able to maintain fairly constant temperatures. The temperature range of the oven follows a normal distribution with a mean of 450 degrees Fahrenheit and a standard deviation of 25 degrees. Leslie Larson, president of the factory, is concerned about the large number of defective cores that have been produced in the past several months. If the oven gets hotter than 475, the core is defective. What is the probability that the oven will cause a core to be defective? What is the probability that the temperature of the oven will range from 460 to 470 degrees Fahrenheit? And let's say it asks you to actually sketch this. So I sketched it offline and I put it in here, and it didn't work very well. Let me do something else. Let me go back here and import it this way. So all this time you can just pretend I'm sketching it. So there is our graph, our sketch. It didn't ask me to graph it, it asked me to sketch it. All I'm trying to do is draw a little picture kind of accurate to what it is. So in the first picture, what's the probability that x is greater than 475? Well, I've made a bell-shaped curve, just eyeballed it. I put the mean, which is approximately at the peak of it. I put -1 standard deviation, which takes me down to 425, and +1 standard deviation, which takes me up to 475, which is the item of interest. I want the probability greater than 475, so I shade in the area greater than 475. That's the probability I want to take. It's an upper tail probability. The next one is, what's the probability that's between 460 and 470? Now, I could have drawn it on a bigger scale and spread it out a little bit more and gotten the same effect, but I tried to make it about the same size as the previous one. So there's my mean, my 450. There's my +1 standard deviation of 475, and 460 to 470 is here, and I shaded this part greater than 460 and less than 470. It's an in between. So now I can solve the problem. And when a problem asks you to sketch a normal distribution, they don't want you to graph it accurately and exactly. They want you to draw a sketch. It's not a graph, it's a sketch, so that I have the understanding that you understand what you're looking for. So let's do part A. So I want the probability that x is greater than 475. And I can't do that. I can find out the cumulative distribution gives me less than that. So what I really want to do is write less than. I want to find that first. X is less than 475. And let's make this bigger so you can see it. We've already done the sketch part, so I think you've gotten a feel for what that looks like. Let's look at this. What's the probability that x is less than 455? Well, that's equal to norm dot dist. And what are the things? We want the x value, so that's 475. What is the mean? 450. What's the standard deviation? 25. And 1, because we want cumulative distribution. That gives me 0.8413, lots of decimal places. Let's take it down to 841. So the probability that x is greater than that is what? I would write that's equal to 1 minus the probability that it's less than. That would be the non-shaded area here. I want this probability. So it gives me 15.9% chance that I'm going to have a defective core. That's a pretty high defect rate. Let's move up a little bit so we can see the second picture. And now I want B. Well, I can only find less than, so I do the probability that x is less than 470. And I do the probability that x is less than 460. Well, less than 470 will be this shaded area and all the white on this side. Less than 460 would just be all the white, or I guess gray, on this side. Less than 460. So if I take less than 470 and subtract off less than 460, I should get the in between, as we well know. So norm.dist. What do I want? Oops, sorry, I didn't mean to do that. I want 470, comma, 475, 25, 1, and that gives me that 0.420, 421, and then I want norm.dist of what? I want 460, comma, 450, comma, 25, comma, 1, and if I do that, I get 65. How can that be higher? Did I do something wrong? 460, 450, 425, 470. I made it 475. It's supposed to be 450. Sorry, my bad. So that comes out to be 78. See, I knew this less than 460 could not be higher than 470. I knew I made a mistake. So if I want the in between now, which is a probability of 460 being less than x, being less than 470, what would I get? And let's make that wider so we can see it. It's just going to be this number minus this number, or 13.3%. That's how you solve this. This is how you make a sketch. It's not an exact graph. It just is the best drawing that I can make to visualize what it's actually asking for, that what part of the area under the curve. Remember, we had four parts. We had a lower tail or an upper tail. The upper tail being the complement of the lower tail. We had an in-between. Or if I wanted to calculate what's the probability that the temperature is not between 460 and 470, well, it would be 1 minus this in between. That would give me the probability of both these white areas, this area and this area. So I hope that helps you in your homework for this week, which is still due tonight, but really make it due on Tuesday. I will change the due date on that, and hopefully the sketchy part will help those of you that were confused by it. Thank you very much.